everyone, it's Justin again. Mia and I stopped by the local coffee shop, and while we were ordering, something caught my attention. Check out this recipe card for hot cocoa. It says to use 5/4 teaspoons of sugar and 7/3 ounces of milk. But 5/4? 7/3? How does that even work? By the end of today's lesson, you'll be able to explain why the numerator of an improper fraction is larger than the denominator. You'll also be able to identify and show improper fractions using words, digits, and visual models. Have your guided notes ready, and let's stir up some sweet fractions. We're already familiar with fractions like 1/2 and 3/4, where the numerator is smaller than the denominator. These are actually called proper fractions, and they represent a value that is less than 1 whole. But the amounts of the sugar and milk are different. How are 5/4 and 7/3 different from the proper fractions 1/2 and 3/4? The numerators are greater than the denominators. Check out 7/3. How can we show that with a model? Remember, the denominator tells us how many pieces the whole is split into. So our model should be split into thirds. 1/3, 2/3, 3/3. That filled up 1 whole, but we're not at 7/3 yet. Fortunately, we can draw another whole split into thirds. Here's 4/3. Think about what needs to happen in order to show 7/3. Pause here to continue creating the model for 7/3 in your guided notes. We already had 4/3, and then we add 5/3 and 6/3. We still need 1 more third, so we'll draw another whole split into thirds. And 7/3. There are 7 1/3 size pieces. So what makes a fraction like 7/3 different from a fraction like 3/4? 3/4 can be shown as part of 1 whole, but when the numerator is greater than the denominator, it means we're working with more pieces, and they won't all fit in just 1 whole. Fractions like 7/3 with numerators that are equal to or greater than the denominator are called improper fractions. And an improper fraction has a value that is equal to or greater than 1 whole. So how can we show the 5/4 teaspoons of sugar with a model? Pause here to record your thinking. The denominator 4 means the wholes of this model will split in fourths. The numerator 5 means we have 5 1/4 size pieces. Nice job! All right, let's pick out a table while our hot cocoa is being made. The smell of fresh cocoa and bagels is making me hungry. Ooh, here comes our bagel order. How can we represent the amount of bagel pieces as an improper fraction? We need to count the total number of pieces we're working with for our numerator. So 1, 2, 3, 4 pieces. And how do we know what the denominator should be? We need to ask ourselves how many pieces each whole is split into. Each whole bagel is cut in half. Since each bagel has 2 pieces, 2 is our denominator. If we put all the halves together, we have 4 halves, or 2 whole bagels. Just like proper fractions, improper fractions can be shown with digits, models, and with words. So let's practice. How can 6/6 be shown with digits? With a 6 as the numerator and 6 as the denominator. Right. Pause here to create a visual model that shows 6/6. How many pieces should we split our model into? Since 6 is the denominator, that means that each whole we use needs to be split into sixths. And we should have 6 of them, or 6 sixths, like this. But wait, that isn't greater than 1 whole. Why do you think 6 sixths is considered an improper fraction? Well, 6 sixths can be renamed as 1 whole since it represents all 6 pieces of the whole. How is that different from a proper fraction like 2/3? Proper fractions show part of a whole, and the numerator will always be less than the denominator. But 6 sixths represents a whole number rather than just part of the whole, so it's improper. Check out these models. How can these amounts be shown as improper fractions? Pause the video here to show the improper fractions in digits and in words. This one has wholes that are split into 8 pieces each, so the denominator will be 8. And there are 8 eighths, 16 eighths, and one more for 17 eighths. And the word form is just the same, 17 eighths. Notice how the word form uses a hyphen between the numerator and the denominator. And how many yellow pieces are shown in this model? There are 14 pieces, which is our numerator, and each whole is broken into 4 equal pieces, or fourths. We can name this fraction 14 fourths, both in digits and in words. This coffee shop stop was perfect. Yummy bagels, delicious cocoa, and even more ways to use fractions in real life. So, what did we learn today, besides the fact that hot cocoa and bagels are always a good idea? Well, now you know that improper fractions have numerators that are equal to or greater than their denominator. You also know that improper fractions can be shown with words, digits, and visual models. Be sure to complete the practice questions and extension activities that go with this lesson to practice working with improper fractions. And remember, mathematicians, in math, as in life, every effort adds to your success. I'll see you next time.